Good morning, everybody. Welcome back. Today we're going to be doing a little bit of graphing equations and really looking at how we can graph equations in different ways. We're also going to be looking at how an equation may look like two different things, or two different equations may look different, but they may have very similar qualities. In some cases, they may actually be the same exact equation. So what we're going to do is a couple examples from the book, and I'm going to have you guys try a couple on your own if you still feel like you need the extra practice. But we're going to start by looking at number 1 here, which is sketching the graph of the equation 9x plus 3y equals 18 using intercepts. Now what that means is when x is 0 and when y is 0. So I'm going to write the equation real quick. We've got 9x plus 3y equals 18, just so I remember that. And so we're starting by looking at that equation there. It wants us to know what y is going to be when x equals 0. So let's figure that out. If x is 0, 9 times 0 is 0. 3 times 6 gets us to 18. So that means that 6 has to be our intercept there. Then, if we have when y is 0, what should x equal there? Well, 3 times 0 is 0, and 9 times 2 gets us to 18. So believe it or not, we can find the graph for this equation just by plotting these 2 points. 0, 6, which is right, 1, 2, 3, 4, 5, 6, right here. And 2, 0, which is right here. Now, I'm not using a ruler here. I still got to get one, but what you're going to see is a line graph that looks like that. So we've got the graph for the line 9x plus 3y equals 18. The next part of this is saying to sketch a graph of the equation y equals negative 3x plus 6 on the same coordinate plane. Well, based on that, we know that 6 is our y-intercept, and that we're going to go down 3 and forward 1. Let me write the equation on the other piece of paper. So we've got y equals negative 3x plus 6. And if we're looking at that equation, we're starting at 6. 1, 2, 3, 4, 5, 6. And then we go down 3. 1, 2, 3 over 1. That's going to put us right here. Down 3 over 1. And what we should notice is that if we follow this pattern, and granted, I didn't draw the straightest line here, but if we follow this pattern, we should see that this is actually the same exact line, if you use the ruler especially. And so here's the reason why. Let's say that we're going to try to solve this equation for y. If we're going to rewrite that equation, 9x plus 3y equals 18, and we have to solve for y, well, our first step is going to be subtracting our other variable from each side of the equation. When we do that, these are going to cancel out. We'll be left with 3y equals 18 minus 9x. Then if we want to get y by itself, we would divide by 3, which will give us y equals, well, 18 divided by 3 is 6. And 9 divided by 3 is 3x. Now look at this equation and look at the other equation that they had. By the commutative property, we can switch these two if we consider this adding negative 3x instead. And when we switch, we get the same exact equation. So whether your equation is in standard form, like this equation up here, or slope-intercept form, you can actually get the same exact graph no matter which equation you're graphing. So that's what our purpose is going to be today. We're going to be looking at multiple equations and determining whether or not they are going to be the same equation or not. So we're going to do one more example together, and then you're going to practice a couple in the problem set. So now we're going to do this one, same type of problem. The first one that we're graphing this time is 1/2 x plus 3. So y equals 1/2 x plus 3. So for this equation, what is our y-intercept? Yeah, for this one, our y-intercept is going to be 3. That's our starting point. And what is our slope? Based on this equation, our slope is 1/2, which means that we're going to rise 1 and run 2. Rise 1, run 2. And keep that pattern going. You can also keep that pattern going in the opposite direction as long as you're doing the opposite of what you were doing here. So instead of rising and going forward, you can fall and go backwards as well. So I got a lot of dots to connect this time. Should be a little bit straighter line than our last one. But we've got that whole graph right there. Now we have a second equation, 4x minus 8y equals negative 24. Take a second to figure out, is this going to be the same equation, or is it going to be a different equation? Now we could solve for that for y and see if we can get it in the same form, but we can also just look at the y and the x-intercepts to determine whether or not this is going to be an equivalent equation or not. We've got the equation 4x minus 8y equals negative 24. And if we have that equation there, then we can figure out when x equals 0, y equals what? Well, 4 times 0 is 0. Minus 8 times something has to be 24. That something is going to be 3. So we can already see that y-intercept is going to be the same. Let's see if our x-intercept is going to be any different, though. So that's when y is 0. When y is 0, we've got minus 8 times 0. So really 4 times something has to be negative 24, and that something is negative 6. Let's see. We go back. 1, 2, 3, 4, 5, 6. And would you look at that? It does cross at the same point. Therefore, these two equations are the same equation. It's just that one is written in standard form, while the other one is written in slope-intercept form. It's up to you to decide which form you find easier to graph. Some people like slope-intercept form because it's easy to find lots of points that they can make. Others say, hey, 2 points is enough. I have my x and my y-intercept, and if I use a ruler, I can connect those to make a straight line. I am good with either way, but there are going to be times where it asks for one form versus the other. So what I'd like you guys to try now is going into the problem set, way at the end here, and determining whether the equations for number 1 and number 2 define the same line. So in other words, if we were going to graph both of these equations, would they be the same or would they be different? If you're up for the challenge, try number 3. Write an equation that would define the same line as 7x minus 2y equals 5. For that one, what I would recommend, try to find the x and the y-intercepts first. If you can do that, it might be easy to find what the slope is for that equation as well. As you guys are working on this, if you have any questions, please make sure that you let me know so that I can help you out along the way. But try this out, see how it goes, and we will see you next time.